I'm Dave. Welcome to another old steam power machine shop. The hot weather has somewhat subsided around here, so we're going to get back to running the steam engine. But in the meantime, when it was unbearably hot, I got a few things done with the electric powered machinery. One of which would have been a perfect job for the planer, but I haven't run the planer enough to be familiar with the accuracy of it. So, and he wanted a really accurate job on this. It was a large steam chest cover for a Skinner stationary engine. It was 18 inches square. It belonged to Jim Conca of Engineers Workshop. He has a YouTube channel. You might want to check that out. He's probably got it back by now and is putting it together. Also had a customer with a small 1.5 horsepower hit and miss engine. It was an air-cooled engine, which is a little unusual. Most of those are water-cooled with a cast iron hopper to hold water around the cylinder. This is air-cooled, and it's a sleeve and bore job. I've done them before on this channel, but this has got a couple of little interesting twists to it. So we'll get right to the work at hand, and thanks for all your comments and likes, and I appreciate all the support. Thanks a lot. I want to show you a little bit about this job that came in the shop the other day, and I'm going to take you through it. This is a steam chest cover from a Skinner stationary engine. It's probably 8 or 10 inch bore, and it has a balanced slide valve. And this is an innovation that came along later when the steam pressures got higher and the valve porting got bigger. The amount of force pushing that valve, that slide valve against those ports, got to be so high that it took a lot of power to run the slide valve, and it also caused a lot of wear, so they had to come up with something different. And somebody invented this balanced slide valve system. And it's just one of several innovations to solve that problem. But what they did was they machined a ring in the back side of the slide valve and fitted it with something like a piston ring, kind of a wide piston ring with a wavy washer or coil springs behind it to hold it out against the back side of the steam chest cover. And what that did was it took surface area away from the slide valve that was being acted upon by the steam. It's really kind of a brilliant idea. So in this case, this surface got pitted, worn, warped. There's some pieces out of it here, and there's actually a factory rework here I'll show you. So our problem here today is to resurface this thing and make it flat. And it's really warped. I'll show you with a straight edge. This is a surface ground straight edge that I use to check straightness on automotive cylinder heads, and it's pretty straight. And you can see I can get a 20 thousandths feeler gauge right there. And over here it's probably closer to 30. And back here. Also this way. Not quite so bad, but right there where it's worn. So it's dished. All 4 corners are high. Dish this way, dish that way. So I got it set up here on the G&E shaper. This has got a 32-inch stroke. This cover is about 18-inch square. I made quite a heavy bar back here that bolts into the T-slots. That's got a stud on the outside so I can clamp it down on the four corners, or the two corners. The problem with setting this up is you can't just clamp it down. You can't put a parallel across here and clamp it down, because it will, even though it's really heavy, it will spring it somewhat. And so then you plane it flat and you take it out and the spring relieves itself, and it's not flat, it's not straight. So I have it clamped down here on the corners with blocks right under the clamp. So it's kind of floating in there. It's got a stop up here in front, and it's not being deflected by the clamping. That's the most important thing with planer work or shaper work when you're doing something like this. Here you can see the factory rework. There evidently was a void in the casting here, and it looks like they chiseled it out with a chisel, cut slot in there, and then fitted a piece of copper or brass in there really tight, and then peened it down in there and filed it off, and it's been there ever since, and it's perfectly smooth across there, and you can't even feel the edges at all. So this is from before welding, and probably before acetylene brazing was used much, and that's how they saved this casting to use, because that's a critical area right there where these where the balance valve ring slid back and forth. The light coming in that window is really bad, but maybe you can see the dial indicator here when I move it back and forth. And that's just on the edge. In the middle, it's worse yet. This is just an exploratory pass across the top, real careful to see where we're at. And as you can see, it's cutting on the ends, but not in the middle. Now you can see the patterns here with the corners being high, and I just wanted to take this light cut across here to make sure that I was sort of averaged out on it. This over here is a little low, but I stopped the tool right above it and checked it with a feeler gauge, and it's only about 5 thousandths behind the rest. So We're pretty good. Now we can take a pretty good cut. Well, that's after the second pass, and I can get a 15 thousandths under there no problem at all. So I'm going to take another 15. This pass should clean it up pretty good. Then maybe I'll follow it with a finish pass with a different tool and a finer feed. It's a finish cut, about 3 thousandths, and I've got a slightly rounded nose tool in there. There's the finished part. Nice surface finish on it. Should work fine. This is a boring mill job that came in here. I thought I'd show it to you. I'm doing it on a 1939 2.5 inch Giddings and Lewis boring mill, which is about the smallest boring mill that was ever made. And it's really handy for doing stuff like this. I don't know the make here, but this is an air-cooled hit and miss cylinder. It's about 11 inches long and about 3 3/4 bore. The cylinder has been honed on and bored on, and it's like way oversized and still pitted. So this customer, I've done a couple of other ones for him too. Brought it in here, wanted to sleeve it, and then bore the sleeve to match the piston. And the piston is in pretty good shape. I mic'd it, it's just a couple of thousandths wear on it, so it should make a pretty good job out of it. I engineered up this bracket system here to hold it in the mill, and now I'm in the process of tapping things around and lining things up to get it to run straight through the cylinder. Do that with this blunt thing in the cutter hole with a feeler gauge, checking top, bottom, side, then run it through, check the back, top, bottom, and side, change it, run it through. Of course, what you do back here affects what it does up here, so you got to keep playing with it. And so I can get it pretty straight through there with what's left of the cylinder. And it's got to go a long ways anyway. I'm using an 1/8 inch thick sleeve, so we've got quite a ways to go. One thing I did do since the last boring mill job that you saw is I added another station here for a tool. It's about 8 inches closer to the end, so I can run the tailstock up tighter and reduce the amount of distance between the headstock and the tailstock, which should be a good thing. And it still gives me about 11 inches up to here and 2 inches left before I get to the end here, to the head. So that should work out fine. It should work out well with other cylinders about this size, the smaller hit and miss engines. Well, for getting it roughly lined up, I'm going to use the way the old timers did it, with a gauge like this. You can get a lot closer than you think. Got it lined up pretty good. I'll swing around here so you can see the whole setup. So I'm going to take a trial pass down through there and see how it touches off. This is the second try. I changed the setup. I moved the table a couple of thousandths to the right, touching off all the way around now and taking about a 3,000. So I know I'm in the middle.
Okay, so now we gotta measure the sleeve. I did this a couple times before for you, so I won't bore you by showing you how to do it again. But the idea here is you measure it in 6 places. $3,941. $941. 3. 90 degrees. And 415. Add those up and divide by 6. Okay, here's the deal. Add them up, you get 23.6470 divided by 2, you get 3,941.1. So this thing is pretty straight. It always amazed me how they could do that with cast iron. I know these are centrifugally cast and ground, but they hold their shape pretty good. Within about 6/1000ths, and then took a very light cut on a slower feed, kept the speed the same, and stopped here at the shoulder. This measures 10 1/8 inch down from the deck of the cylinder, because the sleeve is 10 1/4. That's a little more than I like to leave there, but that's the longest sleeve I could find. So that'll work fine. It's on dimension now of the sleeve, less about 1.5 thousandths interference for a press fit. So now we'll set it up and press it in. This is the hydraulic setup to press in the sleeve. far as the stroke on the pump. But it does save a lot of time because it doesn't mess my setup up. I have to bore the sleeve out to fit the piston. Sleeve is pressed down tight against the shoulder. It took about 4.5 tons on the gauge to press that in there. And now I'm trimming off the excess that's sticking up above the deck. I'm just feeding this in by hand. I might have to float it down a little bit. Doesn't hurt to leave that up just a couple of thousandths. Help with the gasket seal. This cylinder will fit in my honing cabinet, so I've got some coarse stones here. And we'll get out the last 2 or 3 thousandths with a coarse stone and then follow it with a fine stone.
I've got this set for 3.746. So I've got a little over 1,000 left to go. And you can see in 10 inches, you've got just about no taper. Changing over to finer stones. These are shorter, so it's got to come up higher. So I got to set this trip switch. Lower. I don't know if you can see that crosshatch, but that's just about what you're looking for. About a 30-degree crosshatch. This is just an extra check on the clearance. This is a 6/1000 feeler gauge. Just slides in there with a little bit of pressure. So I know we got 6/1000 clearance.